those of you playing at home, there's your homework. 23 to 28. By the way, toolkit, still useful. That's why I put things on my slides so I don't forget. Your toolkit for Math 7 content, CC2, still has all kinds of useful information. So as you're working through your practice work, you should still be using your toolkit. Anybody have one that I can borrow for a second? Sure. Let me borrow your toolkit. And Chapter 8, because we're relatively just starting it, they have... What's so important that you're talking about? You guys are on schedule 1 now. The original one that we had for a long time. Golden told me schedule 1.
This category said something different.
Okay.
This category said ELA and science just splits because global cultures and connections still need to be blocked.
So we have science after.
Okay.
So if you had, you should
That
have.
might be the same. That might be the same.
No. Science actually has.
Okay, so do you guys know where you're going?
Yes.
Can somebody make sure Ian doesn't get lost?
Yeah.
Okay.
We're on science. Wait, what?
Just make sure, just follow your friends that are in your letter group. So, back on your toolkit, because I would like to give you homework time at the end of class and you need to keep moving forward. Notice how much information this actually has in it. It's got describing data distributions. It's got scaling, like how we deal with those percent problems. It's got quartiles and interquartile range. So those of you who are like, hey, you couldn't figure out what IQR was in my latest ruling. It's user resources. It's got a whole section about stem and leaf plots. So the reason that I put that on there that I wanted to talk about is I'm trying to figure out how to say this with being honest but yet not being mean. Some of you just aren't putting in the effort. I get it. The end of February, winter in Ohio sucks. You've been trapped inside for a long time. But when you are handed a bunch of resources, like let's say I go to change the oil in my car. I've been using car analogies, so I think I'm going to do basic car maintenance with my Boy Scout class this week or at some point. If I go to change the oil in my car and somebody hands me all the tools that I need, I'm like, sweet, that's great. I'm going to use my Swiss Army knife instead. It's not going to work. I'm not going to be able to get the job done because I ignored the tools that were handed to me and I just tried to do it with what I have on me, right? Like I often outside of school have a Swiss Army knife on me because that's me, right? I'm like Boy Scout. But that's not going to change the oil in a car. You have to get the right tools. That's why that's called a toolkit. It's what you need to complete the job. So please continue to use that as a reference. I don't care if you write that. I don't care if you use that graph paper. Use it as a reference, though, guys. If you have a question, CPM has anticipated your question, and it's there. It's either in your glossary, table, or your index, your toolkit. You've got it. You've got everything you need. So, as you saw, my desks were a little bit different today. I'm tired of always having to rearrange desks, so if you can try to put the desk back into, no, not right now. Like when you leave, kind of like the concentric arcs. So we have like a front row, a middle row, and then just like an outside big arc, leaving a way to get into the class. That would be fantastic because as you can see right now, it's kind of awkward to get out of class because somebody pulled that desk up. So, I have a feeling that this is a losing battle, but if we try to keep somewhat of 3 concentric arcs. If you move a desk when you come in, just shove it back where it was when you leave. Maybe? Yes, potentially.
Yes.
Now, Math 7 is right before you guys, so that doesn't always work because that's quick transition. So the goal, like what I had this morning was 4 in this row, 4 I believe in this row too, either 4 or 5. That one got shifted somehow. You're fine. And then the big like arc around the back, gap, arc around the side. So if when you guys leave, you can try to shove desks back that way, I would appreciate it more than you even realize. Because of all the things I need to do, moving desks does not need to be a priority of mine. All right, that was a long start up the class. How you guys doing?
I'm doing okay.
Doing okay.
She rolled her ankle yesterday.
I know. I've done that a lot too.
Yeah, he's the one who made me go to the bus early.
I'll tell you a story later. So today we're getting into data distributions, histograms, box and whisker plots, all that stuff. By the way, the technical name is just a box plot. We don't say things like Whisker when you get up into the technical world of mathematics. So if you were at like an engineering firm and you're like, let's represent this using a box and whisker plot, they're gonna look at you like, dude, Boxplot? That's the real name, right? Boxplot. Somebody came in and they're like, what's a Boxplot? It's the real name. Josh is trying to decide his club. Anyone golf here? Actually, I'm just gonna golf. So wedges and irons have different angles to their head. So the golf club, when the pole comes down, the head on like a putter is like straight up. A driver, almost straight up because you're trying to get a lot of accurate distance. Wedges and irons then start to angle the head. So if you hit the ball like this, it's going to pop up and arc as opposed to drive outward long. So Josh has kept track of his distances. He is a data junkie. And he's got the distances that he has gone with his wedge and with his 8-iron. So we want to create a histogram of this and show the distribution. Now, unfortunately, because his hits don't, just get longer as they go, data's not in order right now. So your first task should be put your data in order. Then we want to create a histogram and a box plot for each of these. And you guys can read. So we're going to work through this and try to solve it. I'm going to give you a few minutes. You guys should not be waiting on me, by the way. When you go to do a histogram, histogram is like a frequency table where they plot up against each other. You can either, I put both labelings here, label at your split points, 5, 10, I could label here is 15, here is 20, or, and you should have seen this in the homework, below the bars, tell what numbers are in there. 0 to 5, 6 to 10. We don't have any partial numbers, right? So I can just work in integers. 11 to 15, 16 to 20. because we're not going to use any numbers twice. Your box plot can be on a shared number line, but your histograms should be independent. Yeah, histograms are going to need to be shown independently. That's not really what history is supposed to do. Because history is supposed to show one set of data clumped together, exactly showing your frequencies. It'd be like a modified histogram that wouldn't really show your data correctly. Right, right. So I want to put my wedge data in order. 0, 1. Somebody just verify. Tell me if I goof up. Plus you. And 8 iron. I haven't been golfing in a long time. There's one of the cheaper places to golf in Columbus is the airport golf course, because they're right under the flight path of Columbus Airport, which if you live there, that would suck, right? Planes right over your, but when you're golfing, who cares? Like, just outside, just in the open, you're like, oh, hey, look, plane. So if you want to go golf, ask your parents to take you to the airport golf course. It's cheaper. Or if there's anywhere around here that you know to go. 3, 5, 7. Two 10s.
Yeah. There's the safari golf course.
Oh yeah, I forgot about that one. Have you guys broken this up into quartiles? Ian, you got your median in quartile 1, quartile 3?
I'm working on my
Is that what you're talking about? Is that what you're talking about? Then stop talking. I'm tired of correcting behavior. It's 7th grade. It's March. Okay, no, it's 2 days away, but it might as well be March.
Yeah, 19 and 14.
19, 20.
Yes, sir.
Once I have my data in order, guys, if you don't have your data in order, write this down. Like we talked about, put in that effort. By the way, if I haven't had this direct conversation, there is a route of the path that you are on that detours back into regular Math 8. So please understand, as we wrap up these last 2 months and jump back into the 8th grade textbook and finish up the harder 7th grade stuff, you don't put in the effort to master these standards and you don't finish the 8th grade stuff you need to, we will put you in regular Math 8 next year, because I will not do that to Mr. Hall to place you incorrectly. I will not put you into Math 1, like the accelerated 8, but really we just call it Math 1. I will not put you in that class if you're not ready. So those of you that need to bump up your effort on practice work, or you're giving a hoot about getting assignments done on time, this message is for you. Right? There is a path that would take you back into regular Math 8. You're not locked in this route. What's the first thing I do once I have my data in order? Pull out a giant sword. Okay. And I cut it in half. Right, I just want to get my data in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Crap. 10 numbers don't have a middle. Will?
The answer's 4 because 3 and 5 are the like middle ones, and because you need to find the middle between 3 and 5, it takes you to
So your median value is 4, even though that number doesn't exist. That is also quartile 2. Q2. Your median is quartile 2. Then, what do I do? Rachel?
Are we doing the box?
Yes.
Okay.
Well,
So-
my goal is to do the box plot.
So you find the median from the first.
Yeah, well, first 5. Right, because I had 10 to start. I didn't use the 3, so it's still a number on my bottom half.
Okay. And then your median.
Yeah, so this is quartile 1, and this is quartile 3. If you have not done that for the 8 iron, please find your median and your quartiles. Quartile 1 should be 8, quartile 2 should be 10.5, quartile 3 should be 12. We can do both box and whisker plots on the same number line, on the same graph. Because we don't put them on top of each other, we just show them in 2 different spaces. Because the y-axis, quote unquote, doesn't really exist in a box and whisker. I really only need the x-axis, and then I just build it. What's the lowest value? What color was that working in? For the wedge, the lowest value is 0, right? He like, muffed a shot. It just stayed there. He was in the sand, or who knows what. It sat there. Went 0, or it went like half a yard. He just rounds down. So what does that mean we do, May? You're not with me, right? I need you with me. So we put a dot at our 0, since that is our first value that we had. We start drawing the whisker over to where? Oliver?
1.5. What? Iron?
I'm doing the wedge.
Oh. Yeah.
Quartile 1's 2, dude.
Oh.
You with us? Checking your work up here? So, here's where I think your issue came in. This is your median, and it doesn't use the 3 or 5, so those numbers stay in the bottom half and top half. Giving us 5 digits down here, 5 digits up here. Please adjust that on your paper. Quartile 2 is 2, so this whisker will only go until 2. So I made my numbers a little close to each other, I guess. So right here.
Right. Yeah, that'd be right.
Why no? But these are just kind of. I don't have much of a whisker. So then I start my box, and where's that go to? Well, the median's 4. So I'm going to draw the middle of my box. Connect over. Next line's at where? 15. Ooh.
Whoa. Yeah, it's still only and then the whiskers. It goes up to 25. Yeah.
Sorry, my smartboard's not lined up today, and it's goofing me out. Sweet. So that is the wedge, right? So yeah, I can draw another box whisker set for iron. What's the lowest one for the iron? 3. So right about here, probably. What's the quartile 1?
8.
What's quartile 2?
10.5. Or
What's quartile 3?
12.
Oh, snap.
And it goes to 20. And yet that's still. Hold on,
His first shot is long, right? It's like 130 yards. I'm not even looking at the right thing. It's like 130 yards, right? Or something they tell us. All right, first hole's 130 yards long. So what do we really want here? When you are driving off the tee box or when you're making your first shot on the hole, this isn't actually that long of a hole. 130 yards is not very far. That is from essentially end of the end zone on a football field to the end of the other end zone. Add 10 yards to that, and that's how far this hole is. What is the box and whisker plot? What's the point of this again? Who can remind us? Okay, that's the point of this specific question. But what's the point of a box plot?
Show the spread of data.
How so? Who?
Well, instead of using a number line and having graphing every single point between each one on the histogram, it's way easier to look at the spread of data and find the median.
Okay, so make a pick right now. Wedge or iron in your head, make a pick. Then let's go make some histograms. I'm gonna do wedge first. Yeah, I want blue. So this will be for our wedge. They told me to make bins of width 5, so my bins are 5 wide, 0 to 5, 6 to 10, yada yada. How many go in my 0 to 5 bin for my wedge? Just give them to me.
6.
6. How many go in 6 to 10? 11 to 15?
1.
16 to 20? Nope. Nope.
And then 20.
How many?
2.
2? And nothing, right? Because we did not go above 25. If we do the iron, 0 to 5? Now I'm putting 5 in this, right? Because I heard somebody else say, oh.
Yeah, I've been doing including 10.
If you label down here appropriately, that's fine. 0, 1, 2, 3, 4 can be thought of as 5 numbers, or 1, 2, 3, 4, 5. I mean, so it's up to you, but then, yeah, they just need to be the same widths. So sorry, 6 to 10 was?
5 is English 10.
5 again. So, I mean, you can just shout them out if you want. Or do you have a question, Lena? What's your question?
So what if we had one that was like 5.5?
That's why you have to make a cut somewhere. So, like, if I was making this 0 to 5, this will be anything over 5. So, like, 5 point anything up to 10. And that's why I just say 5 right here. Anything under 5, like, up, anything under and up to, depending on how. So there's different graphs called floor and ceiling graphs. A floor includes the number at the bottom. A ceiling includes the number at the top. So this is what we'd be talking about as like a ceiling graph. 5 is my ceiling. I'm going to include everything up to and include 5. But as soon as I go above 5, like 5.0000001 goes in this thing. But because we're not working with partial numbers here, I just said 6. So anything bigger than 5, 6 is our first bigger than 5 number. How many in 16 to 20?
2.
We need a long hit. You say B is higher, like the iron, this one? Why do you say that? Okay. The highest range of my frequencies, my distributions, are tied in the 6 to 15 range. Right? If I look here at the wedge, our highest distribution is in the 0 to 5. But I have a bar here in the 21 to 25. A couple times I got lucky. And over here I didn't. Sorry, Izzy. Look.
We don't even look alike.
I'm not saying look like look. I just mean like look.
No, I'm saying
Lots of names in my head.
I just like iron. It has a more like the wedge, the higher, you have a more higher chance of getting in the 0 to 5 range. But without iron, you have a more likely to go a little bit further. Not with pencil.
I'm very sorry.
I'm gonna die.
Think well. Wow. Oh, yeah. Oh, terrible.
Wait, what did I say?
She said, I think we'll all be okay if you die.
I would definitely not. Alright, moving on. Be nice. Think before you speak. Sometimes it comes out wrong. Sometimes it comes out wrong. Okay. Our histogram, our box plot breaks things up into 25% chunks, right? So what I could say, based off this, is what? The wall?
For the wedge, you could say half of his hits were between 2 and 15 yards.
For the wedge? Okay, so that like you're splitting here and here. Yeah. You could also say half of his hits were above 4, or whatever that was. You could also say half his hits were less than 4, right? That's that wouldn't really make you feel good if you said it like that. Whereas if I split this in half here, half my hits, my midpoint, is 10, right? Is pretty high. I could even look right here. What percent is above that mark? 75, right? 75% of his shots were at 8 or above, or whatever that mark was. Whereas if I look here and I look at the top 75%, and that was like a 2 or something. That wasn't even good.
Wait.
Who?
So, I averaged, I found the percent out of, how do I explain it? From 6 to 15 in both the graphs, I tried to find the percent out of 100 of the chance of him hitting 6 to 15 on a yard.
For which?
For both.
Oh, okay.
So,
But you're not using the graphs, then you're using the amount of numbers?
Yeah.
You want to use the graphs. So I like what you're doing. You're saying like how many fit in this, and you were doing probability, but we're not really looking at probability. What you really want to look for here is concentration of results. Wide results, and you guys should kind of be aware of this from science fair. If your results are spread out, are those good findings? I mean, it depends on what you're looking for, but if your target is long shots and they're all spread out, I might have made a couple long shots, but a lot of them are down here. This is really tight. 25%, 50% is that close to each other. And 75% is still pretty tight. So you want concentration to show consistent data, which then on a histogram, Anyone ever heard of a bell curve?
Yeah.
Standard distributed data. If it follows a standard distribution, looks like a bell. Kind of looks like a bell. Poorly distributed, because like a bell, looks like this, and it has a ringer on it, and the thing swings around. Yeah. This graph
That's an upside down bell.
is not good. Most of your distributions down here, you've got like a little blip over here. Nah, no. So this is consistent, right? They're close, they're tight. There's no gaps in your histograms. Consistent data. The wedge, I think he needs more practice. He needs to do some better work. All right, we got to move on. Sorry, we are using way too much time for this. Question?
No, I had an observation.
Well, go fast.
Iron is like, it's like a good roller coaster, and then wedge is like a cool roller
Yeah.
coaster.
Oh. I would rather ride wedge. Yeah.
So, I'm gonna throw the other graph up on the TV while we look at these.
That's like a good job.
So if you look at your box plot, right? And sorry that I keep moving this accidentally.
Oh, so we're supposed to find the interquartile range.
So, review. Now this is real easy if we bump back one, right? What's the interquartile range for the wedge?
13.
Okay, yes, 13. Use a hand. Or no, we'll just go class answers. Interquartile range for the iron. 4. 4 closer, right? Tighter together. So, and I'm just going to go through this, make sure we hit check all these boxes. So, 8 to 12, right, that's what you expect. Your middle distribution. You expect that anything out here was kind of lucky. It's the longer. And anything down here was like unlucky. Like that's a bad shot. We look at the center, 50%. Right, so maybe today you're able to do 8 backflips, but normally you can only do 3. 8 is an outlier. So take that back. Not necessarily an outlier, but not in the normal trend. Right? Here, really widespread, really tight together. I think that's it. So if he uses a wedge, what's the typical or anticipated distance outcome? 2 to 15. Right, the center 50% is what will be typical, as opposed to the that was a great shot, or that one was terrible. Normal is in the middle 50%. Let's try this real quick. Make sure that we can arrange data and everything else. So take Jaina and Alejandra, and essentially we're trying to figure out who's better. Parallel box plots is a fancy name for what we just did. 2 box plots on the same number line.
Whoa.
No.
We're making a box plot, right?
Yes, parallel box plots. Does it really hurt? So the first thing we really need to do is put this data in. I don't think you guys really need to do the whole problem and have them spell it out on the spot. Alejandra.
Alexandria is a better name.
But that's not her name.
But it can't See, you don't know how to eat. Smart.
Anybody have Jaina in order for me?
Yeah.
I have some of it. No.
Give it to me.
6, 7, 7, 7, 7. And then 4 9s. And then 4 11s. Yep. And then 46 and 50.
Wait, 4 11s?
Yeah. Oh yeah, 4 11s. 19. Rachel said it. 46. Wait, no, not 19. Mia lied. 19's next.
I'm not a liar.
Oh,
no,
no,
there is
19. I'm a liar.
46.
And then 46 and then 5. And then the next one too.
I have the next one.
Yes, you are. 9, 13, 215.
Hold on. Hey, this won't work if you run ahead of me. 2 17s.
18. Done.
Really, once you get good at this, you should be able to visualize what you're going to end up with by making notations in your list of data. Mark your median, then mark quartile 1 and mark quartile 3. $16 data points for Jaina? Yes? Maybe?
Yeah.
Question or answer? Alejandra. What? Well, we had 2 9s here for the median, right? So because I have an even amount of data, there's no middle. However, in between 9 and 9 is 9. So quartile 2 is 9. Quartile 1, I still have an even amount. 1, 2, 3, 4, 5, 6, 7, 8. So I need to go 1, 2, 3, 4 on each side.
I thought you said if there's an odd number in the start, then you have to have 2 even numbers.
Not necessarily. What's half of 14? What's half of 16? You can have even, like, you can end up with all even splits. So you hope that you end up with odd top and bottom.
Yeah.
But here we don't. So quartile 1 is 7. And quartile 3, 1, 2, 3, 4, is 11. So my spread between my quartiles, my interquartile range, is only 4. It's not that big. Now if I go look at Alejandra, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, my median is 15. 1, 2, 3, 4. 13. 17.
That's only 4. So they're equal.
So if their interquartile ranges have the same widths, right? They're both 4. Who would you pick and why? All right.
I'm struggling with her name too. The A, Alejandra. Yeah, Alejandra. Because for her quartiles, 50% of her shots are from 13, or 50% of the amount of points she scored a game is 13 to 17, where the 50% for the other player is from 7 to 11, which is less than that.
Now Jaina walks up. Jaina says, well, this is not fair.
No.
My average score is better than hers. What would your response be? Well, hey, hold up, actually. That has nothing to do with it. How many games were played? Sorry to interrupt you, but I heard that a couple people say it. You're going to divide by how many data points. Right? So averages don't care how many because you divide by that. So, Will,
She had way more numbers to have.
that still doesn't matter. So, hold on. What I'm really asking here is the mean fair. Hold on. I'm coming back.
So, if there's 3
Add them up, divide by 3.
No, I know that. But so wouldn't it also count though, like make a big difference if the next number is all of a sudden like 250? Because that's only adding one number, but like a huge.
So what are you really trying to say about why?
I'm saying, like, would that be bad or good?
It depends. That's what I'm getting at here.
Oh.
So if the extra number, the extra data point, is very similar to what you already have, it literally is not going to change anything. It could actually have 0 effect. Sometimes adding in another data point doesn't change anything. Izzy.
But Gina has 2 outlines, the 46 and the 55.
These don't fit her data at all, right? Those are nowhere close. Maybe those are games where the other team didn't show up, or who knows what happened. But because Jaina has outlier points, she would of course want to argue use the average, because that's going to pull her average up. When in reality, 50% of the time, she's resulting somewhere in there, and that's not that high. Not bad, but you could do better. Alejandra, while having less data points, still has an average that would match her data. It wouldn't be really wonky, and 50% of her shots are ending up in a higher range. Questions? Please do your homework. Please use your toolkit as you need. Oh, so when I rolled my ankle the one time, I'm skating downhill on a sidewalk, and like roller skating, like blades, and my foot goes off the sidewalk and catches like a grass chunk, and as I'm going downhill sideways, my leg just so then I was skating 2 Boy Scouts, and I just couldn't, I was like, I gotta get there. I was like, what else am I gonna do? I didn't have a cell phone, right? This is before cell phones. So I just like sat down, ratcheted my skate even tighter, like compressed my ankle, and just skated down. Skated down the way. So when I got there, I took it off, and was like, oh, this hurt. And immediately started swelling, and it turned black. But if you can keep compression on it, it'll keep it from swelling. Yeah, it was bad. The only time that was probably worse than that was when I jumped off wire risers, like off the back of it, and ours would flip upward and roll as opposed to like holding. And I landed on one of the wheels, and my ankle just like I heard a pop on that, and that was real bad. In the middle of swim season, my swim coach was very angry. When I came in, like wrapped up and everything, I'm like, I hurt myself in the fire. He thought we were joking at first, because we would like try to play jokes on you. He's like, you're funny, we're gonna meet tomorrow. I get it, haha. I'm like, no, man. Like, I can't walk. Like, I got hurt in choir. I'm sorry.
That's what my like.
Aren't lister injuries from it too? I mean, what I do.